Hello everyone. Greetings, whether it's afternoon, morning, or evening. Welcome to week 3 of DIT 400. So today we're going to be covering some very important stuff, which I'm super excited about. So last week we learned how to create objects, but the thing is, we didn't actually talk about what happens when you create your object. So in this particular session, we're going to be uncovering what happens when you actually run your Java code. We want to understand a lot of things, but more specifically, we want to understand what actually happens to your computer's memory. So, to kind of help us with that, right, we're going to talk about some fundamental concepts like memory management. This is going to tell us where does everything actually go. We're going to talk about references, which talks about what your variables are actually pointing at. We're going to talk about debugging, where we would talk about how you can actually examine your code in real time to kind of explore what's really going on within your code. Now, this is what actually separates a programmer who understand how their code works from someone who just writes code. So by the end of this session, you should be able to identify these bugs that actually confuse a lot of people, right? And you should be in a place where you can fix them without any issues. So bugs should no longer confuse you. So that's why I'm super excited about this session. All right, let's talk about what we covered last week. So to just kind of help ourselves remember. So we talked about a class where we define this as a blueprint that defines what our object holds. That's the data that our object will hold and what it can actually do. We talked about an object as being an instance of our class. We talked about instance variables where we said our objects can actually get copies of their own data. Then we also talked about methods, which basically define what an object can actually do. Then lastly, we ended with JUnit 5 tests, where we're using the at annotation to actually write test methods that helped us, verify that our code was actually working the way we wanted it to work. Now, let's jump into today's class, which I'm excited about. Let's talk about the memory model, where we talk about the stack versus the heap. Here's a way that I want you to think about this. I want you to think about a building that's having two different rooms, right? The first room will be called the stack. Now, think of this as a temporal place. Now, here's a good analogy. If you work for, you're a customer service representative, maybe you work for MTN, Airtel, or Zamtel, or an ISP, right? And then a customer calls you and says, here's my name, here's the problem that I'm facing. You want to write that on a whiteboard. Or another analogy would be how we normally do it in class, where we have a big whiteboard and then a lecturer can write a few notes, and then after that they can be erased. So that's kind of how the stack works, right? When methods start, when local variables are created, all those things are pushed into the stack. Now when the method ends, everything gets wiped away. So why is this cool? It's cool because it's fast, it's organized, and it's temporary. Here's the second building that you want to think about. It's the heap. Now, here's how you want to think of the heap. Think of a large warehouse, right? So, in a large warehouse, you have a situation where goods are brought in and then they're stored in the shelves. So, they stay there until nobody comes to claim them. So, in Java, all your objects, the objects that you create, will live in the heap and then they will stay there, or they'll stay as long as they can stay until nothing is actually pointing to them. So when nothing is pointing to them anymore, we have something called the garbage collector that actually cleans them. Now, let's kind of jump, a bit further into this. So let's talk about the two types of variables that can actually be found in Java. Let's start with the simplest ones, which are called the primitive types. Now, a primitive variable is one, where the box is the value. Now, you remember that a variable is a storage location in memory, or you can think of it as a container, right? Now, here's an example. Let's say you have an integer called balance, which has been assigned 1,000. So the variable balance literally contains the number 1,000, right? Because it's a container, right? And we call it balance. Sorry, I can't type this. So in this balance, we get 1,000, right? And boom, we push it in the container. So our container now holds 1,000. Now, in this case, there's no indirection. There's that simply means no pointing anywhere else. So this B directly points to 1,000. So that's why we say, B has been assigned 1,000. So it holds nothing else other than that particular 1,000. Let me see if I can just clear everything here. Okay, so here's the next thing I want to show you. So these are the primitive types that we will mostly see. So we can have like int, which will store whole numbers. We'll have doubles, which can store floating numbers like 3.75 in this case, the GPA. We have Boolean, which can store yes or no values. That's true or false. We can have char, not char, sorry, which can store a letter grade, maybe like A, C. Hopefully, you don't get D's. Nobody's gonna get a D. So you're all smart. So A, right? So single characters. We can have long, which can store NRCs like 1, 2, 3, 4. Ooh, I'm even tired, but you get the point, right? It can store pretty long numbers or very large integers. So this is something that we can have. Now here's an example that I want you to look at. So in this code, when you write int balance assigned to 1,000 and you create another variable, which is a primitive variable, and say int copy is equals to balance, what will happen here is that you have two variables, and these variables are separate. When you change the value of copy, it doesn't affect balance right here, right? So this balance points to this, which is 1,000, and then now copy here at this, on this particular line, copy will have the value of 1,000. However, when we reassign this, copy will now have 500, whereas balance will remain at 1,000. So this does not affect balance in any way. I want you to remember this because references were completely different. And that contrast, the difference, is very important. Let's move on. So let's talk about reference types and why we define them as a remote control model. So a reference variable does not hold the object, it holds the remote control. That means the address of where the object lives in the heap. So here's an analogy, and I think it's gonna make a whole lot of sense. Let me see if I can try and paint this, right? Don't laugh at this phone. I'm trying my best. Okay, so here's a phone. You get the idea. It's a phone. So if you have a number like 2609666 and stuff like that. So I want you to know this. Your phone number is not your phone. However, your phone number does point to your phone, right? Now, if you have two friends, I'm going to try and draw them. Okay? No offense. No offense. I'm really trying my best. Okay. So imagine that these dots are representatives of your number. So this is your number. This is the exact number. That's here and that's here. Now, this, like I said, is a reference to your actual phone. Now, these guys will also have a reference to your actual phone. So they have your number stored in their phones, and your number will refer to your actual phone. So when they call you, your phone is what rings. Similar to how when you have a TV at home, right? And then you click the remote, it responds. So your remote will be a reference to your actual TV. This is kind of the same thing that's happening here. So a reference variable does not hold the object, it holds the address to where the object lives on the heap. Now this is important. I'm going to show you that in just a bit. So the phone number is a reference pointing to your actual phone, which is the object. Your object will be it will live in the heap, and then your reference, which is the reference variable, will be on the stack. So the stack will be saying, hey, this particular me, okay, so me as a variable, I'm pointing to a particular object that exists on the heap. Remember, heap is where it's our warehouse. It's where we store everything, and then the stack is where we keep temporal data. So variable will be pointing to our object which exists on the heap. Okay, so let me clear this and show you the next thing here. Let me give you this particular example. So if you look at this code, when we write SEC2 is equals to SEC1, this simply means that the exact information that's held in SEC1 is the exact information that's held in SEC2. Remember, I did tell you that this is the major contrast between primitive types or primitive variables and reference variables. So when SEC2 changes, notice here we change the balance. SEC1 gets changed as well. Because remember, initially it's got this value, right? But when a change happens, it gets reassigned, right? So it gets reassigned to 5,000. So both of these are now pointing to the same particular balance. So here's a common mistake. So most people would think, beginners would think SEC1 and SEC2 are two separate objects. They're not. They are both pointing to the same thing. And this is what actually makes reference variables actually powerful, right? And very different from primitive variables. So in primitive variables, we notice that if you change one thing, it doesn't affect the other thing. However, in this scenario, it's different. When you update SEC2, so long as it has been referenced to SEC1, it will point to the same thing. So you can think of this as one object existing on the heap, like I gave that example of a phone, and you have two of your friends who have your exact contact, right? So both contacts will be pointing to your phone, similar to how we have the situation SEC1 and SEC2 is pointing to the same thing, which was created here. So notice we only have one keyword new, and that keyword is creating one object. So both of these now point to that particular object. That's pretty much it, and it shouldn't surprise you because most beginners get surprised how is this working. But once you understand references, it makes complete sense. Let's talk about passing objects to methods, right? So when you pass a primitive to a method, the method receives a copy. Now remember, when I say primitive, I'm referring to primitive types, int, double, char, boolean. But when you pass an object, you are passing the remote control. You're passing something that's pointing to the actual object itself. So the method receives the address and then finds the object on the heap and can change it directly. Let's look at this example. Now notice in this example, we have a function called apply bonus. And then what we are passing here is a reference variable. Now, so when we let a call it on line number 5 here, we create a new object. We call it my account. And then we pass our object to our function. Now we increment our balance by 100. And then when we now print out the balance, which is my account here, we notice that the function actually modified the value because remember, this is not a primitive type. This is a reference type. So it's pointing to this particular object and in turn it gets updated. So this is the contrast that I was talking about. If we reverse this and we said add bonus, then we pass in a primitive type and then we increment the amount, this will not affect the actual variable because these are primitive types. And this is the major difference that you want to remember. So primitive types do not affect the number that you pass, right? Especially when we deal with methods like this. So if you pass a primitive type to a method, it doesn't modify it in the slightest. But if you pass a reference variable, it will get modified because the reference variable has this feature, which is like a remote control. It points to a particular address. So you just want to remember that. Now let's talk about this. Let's talk about this now and now pointer. Now, not now, but no, depending on where you're coming from. So no and no pointer. So no means the reference variable is pointing to nothing. So it's like, can you imagine you have a remote control at home, right? Remote control, and then it has no TV. So when you point it, or when you point your remote somewhere, nothing actually happens because you have a reference variable. Think of the remote as a reference variable that points to nothing. That is no in Java. So in Java, when a program crashes, sometimes it's due to you having a reference variable that points to nothing. That will give us the no pointer exception. So in other words, this simply means that you're writing or your reference variable points to nothing. Let me clear this and kind of show you what that actually looks like. So look at this example. We have bank account being a class. So this is our type now. And then we have, because this now is our reference type, right? So we have SEC pointing to no. This means it's not pointing to anything. So this is telling the compiler that, on the heap, there's literally nothing. So in this case, when you try to print the balance, it will give you a no pointer exception. This means SEC is pointing to nothing. Now, this will cause your program to crash. So let's look at this in a real example. So imagine you just start something like student s is equals to reg, which is equals to find student, and you pass in some random ID, then it gives you a no pointer exception. So the reason why this is happening is because there's actually no student that has been found. So in order to fix this, all we have to do is try to check if our reference variable is not equal to no. So if it's not equal to no, then we can actually print the student that has been found. If not, we can print not found. So this is a professional fix that you can actually do. And when you do this, you are writing code very professionally. And this is just the rule that's there. So anytime a method returns an object, especially from a database or search, assume it might be null and check before actually using it. So it's something that you would want to do a whole lot. Finally, let's talk about the object lifecycle, right? More like how we have the software development lifecycle. Let's talk about the lifecycle of an object. So remember, when we defined an object, we said we use the keyword new. So when you use the keyword new, you've actually created something. So something has been born. And what has been born is put or pushed into the heap, and the reference variable points to it. Now remember, the reference variable will be pointing to what's actually on the heap. So the reference variable will be on the stack, and your object will actually exist on the heap. Then, once that thing is alive, you have at least one variable. So at least one variable holds a reference. So it can be read and can actually be modified. Then finally, the object becomes eligible for garbage collection when no variable holds a reference to it anymore. At that point, the JVM will obviously say nobody needs this anymore, and that will help you reclaim your memory. And here's a good example for it. So if you notice on line number 2, we create an object, so the object is born, and then we call new again. Now this is so important because we are calling new. When we call new Momo account, what we've essentially done is we have taken SEC which is our reference variable pointing to this initially. So at this stage, we kind of disconnect it at this stage. Yeah, we disconnect it and reassign it to something new. So the JVM will notice that this is now hanging, and then it will essentially delete that. Now, if you're coming from a programming language like C, you have to handle this. Like, for example, you free, you delete in memory, you have to manually manage all that. Now, in Java, you don't have to do that. So once you reassign your reference variable to a new object, the JVM is intelligent enough to tell the uh, garbage collector to clean that up and remove that on your behalf automatically without you having to do anything. So, which is pretty cool because now you can avoid memory leaks, which often lead to, like your server crashing and can cause like major bugs on your system. So, that's pretty cool. Let's move on to the next thing, which is debugging with VS Code. Now, a breakpoint, uh, let me, even before I talk about the breakpoint, usually when you are programming, we advise that you use print statements, and that's how beginners actually debug. You use a print statement, or, like as we would do system.out.println, but you realize that a real debugger, um, someone who's actually learned these things, will actually use a debugger that lets you pause your program and watch how variables change line by line. And that's the difference between guessing and actually seeing what happens. Now, VS Code does provide us with some really good keys that we can use to do this. So we can use F5 to continue, and that's just going to show us, like where our breakpoint is starting, and then we can go step by step. We can step over and go line by line. And then finally, we can do an F11 to kind of step out of a method. We can use F11 to jump into a method, and we can use Shift F5 to stop or kill the running program. That's a lot of stuff that I've said. Maybe what if I just show you that with an example? So let me get to this part and see if I can switch to VS Code. Okay. So here's a simple program, and all that it's doing is modifying the value of balance. And so as you can see, we create, it's not a big program. So we start with balance equal to 1,000. We make a copy of that balance. And then we have a little function here that is basically reducing the balance. Or it's reducing the money actually, right? Let me not say it's reducing the balance, it's reducing the money, and then it returns this. Now, the reason why this is important is because, like we said, these are primitive types and not reference types. So let's put the breakpoint. So here's how you want to put the breakpoint. So I'll put a breakpoint here. And then I also want to put a breakpoint here. And then we want to jump into the function. So I'll put a breakpoint here. So here we'll be able to pause our function, or our program rather, when we start to run it. So in order to run the program, we'll do F5. So as you can see, it has brought some new stuff, right? So you have some panels here like variables. You can watch what's happening. And here's the cool part, right? So it tells you that right now the balance is set to 1,000. I put a breakpoint here. So let's do F10. And then now you notice we can read the value of copy. So the copy has been assigned to the value of balance, which is 1,000. So we see that copy over here. So we can continue. So we continue on the next line now, and you can even see what's actually happening here. So initial balance, so you can see initial balance there, and then initial copy now. So it shows us what's there. So these are the three tabs that are helping us see what's going on. So we are now on the function, and if we want to jump into the function, all we do is F11. So F11 now shows us that amount, which is what we received here, is at 1,000 right now. And then if I go F10, it's going to show me the new amount, where because amount, will be subtracted from 500. Then we now see the new value of amount, which is 500. In order to shift out of this, I can do Shift 11, and then that takes me out. See, I just went out of this function, and then we have everything as is right now. So that's basically how we get to use um, the debugger, and you can continue going with this, and now you can see the copy is now 500 because we just got the value from there, which is 500, and more changes should continue to take place. After change, you see the balance is still 1,000. To the copy, the balance is 500. So that's basically how we use the debugger, and I'm just going to do Shift F5, and that's going to close everything. You can see a list of the breakpoints that we have. I'm just going to clear everything here and close this and restore that. So that's how we work with the breakpoints. Let me switch back to the PowerPoint presentation, which is going to be, okay, so this one, right? Okay, so we get back to the PowerPoint. So that's how we work with the debugger in VS Code. Here are the three panels that we just explored. So we've got the variables panel, which just shows us everything in scope. We also have the debug console at the bottom, and you can also use it to type expressions and see the values. And as you noticed, you are able to see some of the values. We also have the code stack, which shows which methods code which, and we see how we arrive at the current line of code. So debugging is how you write serious software. So we'll practice this in one of our labs when we meet. So here's the professional debugging workflow that you can use. So set a breakpoint before the suspicious error, some error that you feel is suspicious. Pause while things are still healthy. Look at the variables as you are seeing me do it before stepping anywhere. Sometimes the wrong value is already there before you even start. So meaning the bug is earlier than you actually thought. So you can use F10 to step line by line. And you can obviously think of that as you asking yourself, what do I expect after this line? And then that will essentially help you. And the moment the variable gets the wrong value, that's your bug. So you don't only know the symptom, but you actually know what actually caused that particular bug. So the more you practice this workflow, the easier things get, and the better you become at actually debugging. And especially in the world of AI, you can also see where AI missed a particular thing by using this particular workflow. Here, top 3 mistakes that we would want to avoid. So when you have bank account B is equals to A, this is not a new object. It's actually pointing to the same thing. So if you want to create 2 reference variables, all you have to do is call new to create a separate object. Here's the second thing. Forgetting to check if your reference variable is actually null. You want to remember that so that you do not run into null pointer exceptions. Here's the third thing, expecting primitive changes to reflect back. So we talked about this, where you start to confuse primitive types and reference types, right? So remember, primitive types do not affect anything. So when you make a change here, don't expect it to reflect on the other end. It's completely different. So here are 3 things that we've talked about this week. We've talked about stacks. We talked about them as holding local variables and method frames. We've talked about Heap, which stores all your objects. We've talked about the differences between primitive and reference types. We've also talked about how that 2 reference variables can point to the same object. We've also talked about what no means, and we said it points to nothing, and that it's also important to always check that in our programs. Then we also talked about the automatic power of garbage collection in Java, which helps us free memory, thereby avoiding crashes and bugs developing in our programs. We also talked about how we can use the debugger that lets us pause and inspect memory in real time. So here's the last thing that we've not covered. Imagine somebody just walks up or gets into your code and says SCC.balance is equals to negative 999, that would be problematic. So in next week's class, we're going to talk about the access modifiers, which are ways in which we actually get to protect our objects. So this is it for this particular week. I'm going to hopefully see you in our practical lab. If you have any questions, please write them down and we're going to address them in class when we meet. Otherwise, here's where we're ending this week. God bless you. Have a lovely week. And I hope to see you soon. Bye bye.